Hello everyone, welcome to new class. Today's class is the continuation of the problems on AC circuits. If you didn't watch the first parts, please go through it. The link will be given in the description box. Let us go through the problem. A 100 ohm resistor in series with 120 microfarad capacitor is connected to 230 volt 50 Hz supply. Find the circuit impedance, current, power factor, phase angle, voltage across the resistor and voltage across the capacitor. So this is in the form of RC series circuit. That is, this is RC series circuit with resistance equal to 100 ohm, capacitance C equal to 120 into 10 raised to minus 6 farad. Frequency is 50 Hz. So first we have to find the capacitive reactance X equal to 1 by 2 pi Fc. That is equal to 1 by 2 into 3.14 into 50 into 120 into 10 raised to minus 6 and we get 26.5 ohm. Now we can calculate the impedance. Z is equal to square root of R square plus XC square. That is equal to square root of 100 square plus 26.5 square and is equal to 103.45 ohm. And current I is equal to V by Z, that is equal to 230 divided by 103.45, that is equal to 2.22 ampere. Now we can calculate the power factor. Cos phi is equal to R by Z. R is 100 ohm divided by the magnitude of is impedance, that is 103.45 and is equal to 0.966. And here the power factor is leading because it is given as the series RC circuit. Now the phase angle phi is equal to cos inverse of 0.966, that is equal to 14.98 degree. Now we have to find the voltage across resistor and capacitor. The voltage across resistor are equal to I into R, that is 2.22 into 100 equal to 222 volt. Similarly, the voltage across the capacitor is I into XC, that is 2.22 into 26.5 equal to 58.83 volt. Let us go through another problem. A resistor of resistance 10 ohm, an inductance of 0.3 Henry and a capacitance of 100 microfarad are connected in series across 230 volt 50 Hz mains. Calculate the impedance, current, voltage across resistor, inductor and capacitor, then power in watts and power factor. So this is a series RLC circuit with resistance R is equal to 10 ohm, inductance L is equal to 0.3 Henry and capacitance C is equal to 100 microfarad. Frequency is given as 50 Hz. First we have to find the inductive reactance and capacitive reactance. Inductive reactance XL is equal to 2 pi FL, that is 2 into 3.14 into 50 into 0.3 equal to 94.2 ohm, and X is equal to 1 by 2 pi FC equal to 1 by 2 into 3.14 into 50 into 100 into 10 raised to minus 6 equal to 31.84 ohm. Now we can calculate the impedance Z is equal to square root of R square plus XL minus XC the whole square in the case of series RLC circuit, because here inductive reactance is greater than the capacitive reactance, so use XL minus XC the whole square. That is square root of 10 square plus 94.2 minus 31.84 the whole square equal to 63.15 ohm. Now the current I is equal to V by Z, that is 230 divided by 63.15 equal to 3.64 ampere. Now we have to calculate the voltage across resistor, inductor and capacitor. That is, voltage across the resistor is I into R equal to 3.64 into 10 equal to 36.4 volt, and the voltage across inductor is I into XL, that is 3.64 into 94.2 equal to 342.88 volt, and the voltage across the capacitor is I into XC equal to 3.64 into 31.84 equal to 115.89 volt. Now we have to calculate the power in watts and power factor. Power in watts is VI cos phi. So in this case we have to find cos phi, that is the power factor cos phi is equal to R by Z, that is 10 by 63.15 equal to 0.158. Now the power is equal to VI cos phi, that is 230 into 3.64 into 0.158, and we get 132.27 watts. Let us do another problem in parallel RLC circuits. That is, a voltage of 250 volt at 50 Hz frequency is applied to the circuit shown in the figure. Find current drawn from the source, power factor of the circuit and power consumed. This is the circuit given. So this is a combination of parallel circuit and series circuit. Let 3 ohm plus J5 ohm be the Z1 and Z2 is equal to minus JXC, because here only the value of capacitance is given, so we have to find a impedance Z2 is equal to minus JXC, and Z3 is 2 plus J6 ohm. Z1 is 3 plus J5 ohm, and convert it into polar form, that is 5.83 angle 59.04 degree. Z2 is minus JXC, that is minus JXC is 1 by 2 pi FC, that is minus J 1 by 2 into 3.14 into 50 into 200 into 10 raised to minus 6, and we get minus J 15.92 ohm. And here we have only the imaginary part, so the polar form is 15.92 angle minus 90 degree, and Z3 is given as 2 plus J6 ohm. Now we have to find the equivalent impedance of this circuit. So first of all, find the equivalent impedance of this parallel circuit, that is equivalent impedance of Z1 and Z2. Let it be Z12 equal to Z1 Z2 divided by Z1 plus Z2. For this we have to find Z1 plus Z2, that is Z1 plus Z2 is equal to 3 minus J 10.92, that is Z1 is 3 plus J5 and Z2 is minus J15.92. So we get 3 minus J10.92 and is equal to 11.32 angle minus 74.64 degree in polar form. So the equivalent impedance of Z1 and Z2 is equal to 5.83 angle 59.04 into 15.92 angle minus 90 divided by 11.32 angle minus 74.64 degree. So here multiply 5.83 in with 15.92 and divide with 11.32, and in the case of angles, add the angles in the numerator and subtract the angle in the denominator. So we get 8.2 angle 43.68 degree, that much ohm, and convert into rectangular form, that is 5.93 plus J 5.66 ohm. So the total impedance Z is equal to Z12 plus Z3. Z12 is 5.93 plus J 5.66 plus Z3 is given as 2 plus J6, that is equal to 7.93 plus J 11.66 ohm and is equal to 14.10 angle 55.78 degree in polar form. Now the current I is equal to V by Z, that is 250 angle 0 divided by 14.1 angle 55.78, and we get 17.73 angle minus 55.78 degree ampere. That is, the magnitude of the current is 17.73 ampere and it lags behind the applied voltage by 55.78 degree. Now the power factor cos phi is equal to cos of the angle, that is 55.78 equal to 0.562, and the total power P is equal to VI cos phi, that is 250 into 17.73 into 0.562, that is equal to 2491.06 watts or 2.5 kilowatt. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel for more classes.